how you assemble the product. But know why do you do it that way? The minute you understand why something is done in a particular way, you can do the next. But if you just have the how, you will not be able to do the next. So this is a reflection of us building the why of compressor technology over the last 20 years, right? So this is not something that we just suddenly discovered, sat under the tree, meditated and got it. No, this is deliberate process over multiple years. So I'm very excited about this technology, and this is just the beginning for us. We have a fantastic and exciting journey for the next at least 10 years, introducing innovations of this nature.
Compressed air is one of the largest energy consumers on the shop floor. Power costs of compressed air and reliability of compressors directly influence productivity and profitability. But here's the challenge. Air demand of any factory is never constant. It changes minute by minute, hour by hour, with production schedules, machine pauses, tools used, and the processes involved. Yet most factories rely on fixed-speed compressors, designed to deliver constant compressed air and responds to fluctuations by cycling between cut-in and cut-out pressures. Add to this the reality of oversized compressors chosen for future expansion or to meet peak loads. This exaggerates the cycling. Cycling results in operation above nominal pressure, power consumption without air delivery, and stress on compressor components, resulting in energy loss and reliability issues in long term. This phenomenon is universal. No matter the industry or application, fluctuating demand and energy waste are challenges every factory faces. Introducing ELGi's Demand Match System, a breakthrough solution for the challenges in fixed-speed compressors. Demand Match dynamically adjusts the compressed air delivery to match the real-time plant demand. It works by recirculating airflow within the compressor, maintaining the desired pressure without cycling between cut in and cut out, resulting in no loss of energy, stable operation, and superior reliability. For the factory, the essential benefits include up to 17% energy savings, unseen levels of savings in a fixed-speed compressor, long-term reliability for compressor components enabling errand warranty of up to 10 years on EG series and 5 years on EQ series, a reduced carbon footprint for more sustainable operation, affordable, capital light, and lifetime guarantee. For the first time, a fixed-speed compressor can truly match a factory's demand, every moment, without compromise. The ELGi Demand Match System saves like VFD, costs like fixed.
To take us deeper into the working of this breakthrough system,
with us today, and I hope you have seen the video and the introduction from Dr. J. It is, I must say, it is very, very involved and very deep innovation after understanding the compressors into this. At ELGi, we continuously work on improving customer experience and providing value to customers through innovation. I'll be talking about one such innovation, the demand match system, to you in more detail to understand how it is going to work. I would like to introduce this in a very simple term, simple application, what we generally experience, even today we are experiencing. For example, we used to have standard ACs in this room, we also have the ACs. So if the number of people in the room is more, the AC will be on and it will maintain the comfort zone temperature. And if the number of room people leaves or if the ambient temperature goes down, it becomes off. So AC is to become on and off to maintain the comfort zone depending on the people inside or ambient outside. Later there was a movement to the inverter AC, where again the AC will vary its capacity continuously depending on the number of people added and other things. So it will not go to on and off, but it will change its capacity on and off, so that vary its capacity to deliver it. So in both the situations, when the demand is varying, the AC will work in an unstable mode. So one has some advantage of efficiency and another has disadvantage of efficiency also, the standard one. So to understand better, if there is a demand is varying, the equipment what is serving that demand is going to get fluctuated and it is going to be operated in an unstable manner. So similarly, a compressor, this is the layout of the compressor in a plant. The compressor is connected to the plant and the plant has many utilities. And each of them need air at discrete amount of times and discrete quantum of the thing also. So the demand from the plant is always fluctuating or varying, whereas the compressor output is always constant. So the demand can vary in 2 minutes, because if somebody uses the tools, guns and the nozzles, and somebody uses the spray guns for the painting and other things, the demand will change in less than 2 minutes of time depending on the application, number of people and lines it is there. And there is another way, the demand can be varying in 2 to 5 minutes, because if there is a batch production, machines are starting and stopping, and there is a large pneumatic cylinders are actuating kind of thing when it is happening, the demand varies in 2 to 5 minutes. And demand will vary more than 5 minutes also. For example, on no demand, somebody go for tea or coffee or lunch time, the demand will not be there or it will be very low. And the other scenarios includes demand equal to capacity. It is a very, very ideal situation where the demand is same as the capacity, and sometimes demand is greater than the capacity. Maybe a poor selection of the compressor, their demand is 100, but they selected a compressor of 80. That is another scenario. Or capacity can be significantly greater than the demand. So the demand can be 200. Their capacity, demand can be 100, but they would have selected a 200 compressor, 200 units of compressor. So these are the scenarios any factory will be going to experience. So when this demand is varying like that, how compressor is going to operate? So you can see. So any plant need a definite amount of pressure. So to ensure that pressure, compressor will be operating in 2 zones mainly. The minimum pressure below which the plant cannot run, so they need the minimum pressure, and the maximum pressure, that is called the cutout pressure, where the compressor cannot run and it is not desired to run the compressor above that pressure. And when there is no air, compressor will be operating under no load pressure. So these are the 3 conditions, and the compressor always oscillate between these pressures to maintain the desired output of the plant. And I explained the scenarios. In an ideal scenario, there is no variations. You can see the compressor is going to operate so at standard, and it is very, very ideal. It never happens because the demand is varying. So if the rapid variation, when there is a demand varying in 2 minutes, you can see the number of cut-in and cut-out cycles. Machine will be on, machine will be off, machine will be on, and machine will be off. It won't even come to the no load condition. So there will be a significant cycling between the cut-in and cut-out pressure. So if the gradual variation is there, still the cycling will happen, but the number of cycles will be reduced, the frequency of cycling will be low. And when the extended demand, if somebody goes to tea or coffee or some machine is shut down or they need up later, the machine will have low number of cycling, and sometimes the machine goes to unload conditions. And if there is a wrong selection, if demand is greater than capacity, compressor will never build the pressure. So under any circumstance, the plant has to buy new compressor for this. So in a natural scenario, there is always a demand fluctuation, and compressor is always cycling between the cut-in and cut-out pressures, and this leads to unstable operations. So can VFD help? Normally the variable frequency drives are employed into the compressors. They are becoming popular, but still whether they really help under this scenario. So when in the ideal capacity VFD doesn't work, it will just producing this, and when the demand is more than capacity, still VFD is not going to work. So there are two scenarios VFD will not help. Now, when there is a rapid and gradual scenario, what is happening? The VFD will become ineffective because it is going to rise up and down its speed and try to match the demand. So what happens is it brings new fluctuations with respect to electrical components and also the stress on the electrical components. And moreover, it is 30% expensive. We need to put that one, which it may not be completely solving the problem. So the savings may not always justifiable with respect to the risk. And in some situations, there are some sinus harmonics will come into this. We need filters to normalize those harmonics. Those filters are very expensive. So VFD will become even more costly during that time. So when the demand fluctuating conditions, which is natural, which will happen in any factory, the compressor operates unstable, whether it is fixed or VFD. So what is the impact? Okay, let compressor operate unstable. What do you think? What will be the happening? Okay, so there are two things will happen. We are talking about performance. There is a hidden cost when the compressor is fluctuating. We don't see the cost, but there is a hidden cost. To facilitate the compressor to work between these cut-in and cut-out pressures, the machine always need to operate at above the desired pressure. So operating above desired power pressure is a waste of energy. And every bar excess pressure, if a compressor operates, it is 8% of extra energy it is consuming. So if the required pressure is, let's say, 6.2 bar, if the compressor is operating at 7.2 bar to facilitate this cut-in and cut-outs, it will lose 8%. It will unnecessarily consuming 8% of energy. And second point is, whenever there is a cutout happens, there is no production of there is no air is produced, but still compressor is consuming energy. So there is no productive energy what it is utilizing. So there is a loss here between the cutout and cut-in cycles. So there are two losses because compressor operates at high pressure. There is an 8% up to 8% loss, and there is an unproductive energy because there is compressor still consuming energy without producing the air. Depending on the pattern of the industry and depending upon the time the pattern is existing, this is up to 17% in specific applications. And for example, if a compressor is operating under all these scenarios, up to 6 to 10% will be the average savings we can get from the compressor. The loss will happen when the compressor is operating in these fluctuating conditions. So what about reliability? So compressor has parts, flow related parts, because compressor is generating air, it has oil, it need to handle the flow, it has flow related parts, and compressor to ensure the movements, there are kinematic parts, the motion related parts also available. On the first picture, I am talking about flow related part. It is a separator tank in the compression chamber. And you can see when the demand is fluctuating, the tank is subjected to full flow, half flow, partial flow. So this is subjected to so much of stress onto the components. So there are more than 20 number of such components available in the compressor to handle the flow. And on the right hand side, I am showing the intake valve. There is one of that valve. For making the compressor to on and off, it is going to move, and you can see the actuator. There are 6 movements happening in that to facilitate that movement, and the frequency is so high, this movement is going to be so high, it produces a lot of stress onto the motion components also, or kinematic components. So both flow and kinematic components will get stressed because of the fluctuations, the way in which compressor operate to handle the fluctuating demand. So we have a hidden cost, there is a loss in energy, and there is a reliability issue. So just to conclude, fluctuation demands can cause unstable compressor operation, which cause efficiency and reliability issue. VFDs may try to solve this problem, but they will not be effective in some scenarios like rapid and gradual scenario, and they bring new dynamics like electrical instability and also fluctuating the electrical components. And also VFD sometimes will have overall impact on the plant if they are not managed well to handle the sinusoidal harmonics, what it is going to generate. So this is true no matter the brand or no matter the size and no matter the type of the compressor. So customer is accepted this one, I buy the compressor, it will have this problem, and sometimes it is also unknown because that's where it is going to work. Yeah. So at ELGi base to provide better value to that, do we have any solution? We were working on it. What next? If this is given, everybody is having this problem and customer also cannot do much about it. Can we do something about it? That's where we invented the demand match system. So the demand match system, it's an innovative system. What happens is it automatically adjusts compressor delivery to match the plant demand. So it eliminates instability, it improves efficiency and reliability at optimal cost. So it is not as expensive as VFD, and it provides efficiency and eliminates the instability. The principle is simple, recirculate and recover. This is the principle how this demand match will work, and recirculate the excess capacity within the system. So when the demand is fluctuating, compressor is delivering constant, my requirement is low, it recirculates back the additional capacity back within the compressor system, and capitalize all possible avenues for any loss recovery. When we are recirculating, there could be some loss which I am going to explain further, and we would like to capitalize this loss so that we'll give net benefit to the compressor. So the technique and control are novel here, because recirculation, yeah, I'll recirculate is easy, but where do we recirculate? How do we recirculate without compromising any new failure or introducing new failure modes, but adding value with respect to efficiency and reliability is important. So quickly to understand, in a compression, there are 4 zones. There is a suction zone, stabilization zone, compression zone, and delivery zone. So during suction will happen. In stability, just pressure will become normalized, and compression will happen, and the delivery, compressor will be delivered. You can see the pressure, the pressure is rising in the compression chamber. This is suction, constant pressure. It is raising the pressure, it will get delivered. This is the volume of the compression chamber. So what happens is in the stabilization zone, because air is got accumulated there is a very marginal pressure rise over the ambient. That pressure rise is sufficient to recirculate back air from stabilization zone to suction zone. So during that time, no work is carried out on the air, what is getting recirculated. Up to 30% of the air we can recirculate back within these zones if we were able to locate those zones properly and recirculate them back. So this is one of the recirculation area where we are recirculating the capacity. So when the compressor doesn't need air, when the plant doesn't need air, it just recirculates the desired amount of this to this. And the second area is we will recirculate. The next zone is from the separated tank. We have a tank there, and we will be recirculating back into the suction zone again. One can think when we are recirculating from the tank at the end of the compression, already work is done, we may lose that work. So what we have done is we would like to recover that energy. So when we are recovering, we position such that the inlet pressure will get raised. Previously, you can see the pressure is here. Now the pressure has gone up. The net pressure ratio of the compression will come down. So the overall work will come down. Though there is a loss on the recovery air, will gain on the overall compression. So the net, there is always a gain. So this demand match layout, how we are employing that one, it has 2 valves. One is a stabilizer valve 1, which is connected within recirculating inside the compression chamber, and second one is a stabilizer valve 2, which recirculates back from the separated tank to the suction zone. These valves are positioned and controlled electronically. This is not pneumatically controlled valves where the precision is very difficult to manage. They are controlled electronically through controller, which ensures a precisely positioned and controlled to match exactly what is the demand. The compressor capacity is matched towards that. So This is the general layout, and in the compression, in the current scenario, there is a motor connected to the air end. This is the compression chamber where the compression will happen, and it is controlled by the controller. Now you can see there are two valves positioned here, stabilizer valve 1 and stabilizer valve 2, and there is an intelligent additional logic went into the controller to position them and to make them open continuously to ensure the demand is always matched, the capacity is always matched to the demand. So just to see overall, this is the compressor operation with and without VFD and also demand match. You can see the regular compressor will have fluctuations on the pressure. The VFD compressor will have fluctuations on current, whereas the demand match system will work very stably. And when there is no air requirement, somebody goes to the T, it ensures a long unload condition. There also it saves energy from a customer product. So there will not be any fluctuation in the compressor operation with the demand match system. That's where the innovation will come. And I'd like to play one video just to see how exactly the compressor works without demand match, and when we employ or when demand match, how the compressor will work. This video focuses on one of the actuator of the valve, so that you can just focus on this. The compressor actually operate, and with demand match how it is going to operate. So this is the actuator. Is a significant amount it will save to the customers, and it eliminates why it happens, because it manages the output and demand and also avoids over pressurization, and high reliability because there is no cycling. Compressor operates very stable, so that's where we'll get both performance and reliability benefit. And this is an intellectual property, very important to provide value to our customers, so we have done the patenting and the rights of innovation with us. I hope this gave you clarity on how the compressor system works with the demand match, and that's all from my side. Thank you.
இந்த டெக்னாலஜிங்கிறது வந்து நாங்கள் இதுக்கு பேர் வந்து டிமாண்ட் மேட்ச்னு சொல்லியிருக்கோம். இதோட ஒரு ரியல் பெனிஃபிட் என்னன்னாங்க, இப்போ கம்ப்ரெசர் வந்து 70-80% கம்ப்ரெசர் வந்து ஃபிக்ஸ்ட் ஸ்பீட், அதாவது கம்ப்ரெசர் ஒரே ஸ்பீடில் ஓடும். பட் கஸ்டமருக்கு வந்து கம்ப்ரெஸ்ட் ஏர் வந்து டிமாண்ட் வந்து ஒரே இதில் இருக்காது, வேரி ஆகிட்டே இருக்கும். ஃபஸ்ட் ஷிஃப்ட்லேருந்து செகண்ட் ஷிஃப்ட்லேருந்து தேர்ட் ஷிஃப்டில் வேரி ஆகும். ஒரு ஷிஃப்ட்டுக்குள்ளே மினிட் டு மினிட் கம்ப்ரெசர் ரிக்குவயர்மெண்ட் வேரி ஆகிட்டுருக்கும். பட் ஆனால் கம்ப்ரெசர் வந்து எப்போவுமே ஒரே இதில் ஓடிட்டுருக்கிறதுனால என்ன ஆகுது, கம்ப்ரெசர் வந்து விட்டு ஓடும், ஒரு ரேஞ்சில் விட்டு ஓடும். அது பண்ணும்போது பவர் கன்சம்ஷன் ஜாஸ்தியாகும். இப்போ நாங்கள் இன்ட்ரடியூஸ் பண்ணியிருக்கிற டெக்னாலஜி எப்படின்னா, கம்ப்ரெசர் வந்து ஒரே ஸ்பீடில் கான்ஸ்டண்ட்டாக ஓடும். ஆனால் அதே சமயத்தில் கஸ்டமருக்கு வந்து வேணுங்கிற ஏர் மட்டும்தான் டெலிவர் பண்ணும். அது பண்ணும்போது பவர் கன்சம்ஷன் கம்மியாகுது. ரெண்டாவது, இது விட்டு ஓடுற ஒரு சூழ்நிலையை நம்ம அவாய்ட் பண்ணிடணும். ஸோ கம்ப்ரெசரோட ரிலையபிலிட்டி ஜாஸ்தியாகும். ஸோ அதான் மெயினாக இந்த டெக்னாலஜியோட பெனிஃபிட் வந்து அதுதான். இப்போ அதை எப்படி இது பண்ணுறாங்க, விஎஃப்டின்னு ஒரு டெக்னாலஜி இருக்குதுங்க. ஏசிலெல்லாம் இன்வெர்ட்டர்னு சொல்லுவோம். அதே டெக்னாலஜி கம்ப்ரெசர்லேயும் பயன்படுத்திகிட்டு இருக்கோம். 15 வருஷமாக பண்ணிகிட்ருக்கோம். அந்த விஎஃப்டி வந்து இதே மாதிரி வேணுங்கும்போது ஸ்பீடை மாற்றி ஃப்ளோ மாற்றி கொடுக்கும். பட் அந்த விஎஃப்டி ஒன்று செலவு ரொம்ப ஜாஸ்தி, காஸ்ட் ரொம்ப ஜாஸ்தி. 30 ஃபிக்ஸ்ட் கம்ப்ரெசரை விட இது 30% ஜாஸ்தியாக வரும் விஎஃப்டி. அதே சமயத்தில் எலக்ட்ரானிக்ஸ், அதில் அந்த ஹார்மோனிக்ஸ், இந்த ஃபில்டர்ஸ், அதெல்லாம் அந்த எலக்ட்ரானிக்ஸ் கம்ப்ளெக்சிட்டி விஎஃப்டியில் இருக்கும். இது வந்து பியூர்லி மெக்கானிக்கல் சிஸ்டம், வெரி லிட்டில் எலக்ட்ரானிக் கண்ட்ரோல். இது மெக்கானிக்கலாக நம்ம கண்ட்ரோல் பண்ணுறதுனால ரிலையபிலிட்டி இஸ் வெரி வெரி ஹை. ஸோ இது வந்து உலகத்தில் த ஃபஸ்ட் டைம் இட் இஸ் பீயிங் லான்ச்ட். எந்த கம்பெனிக்கும் இந்த டெக்னாலஜி இல்லை. நாங்கள் இதை டெவலப் பண்ணியிருக்கோம். இந்த கடந்த 1 வருஷமாக இது வந்து நிறைய கஸ்டமர்ஸ்க்கு நம்ம டெஸ்ட் பண்ணியிருக்கோம். ஸோ இது வந்து டெஸ்ட் பண்ணாததில் 6% 17% மட்டும் சேவிங்ஸ் கஸ்டமர்ஸ்க்கு வந்திருக்கு. ஆவரேஜாக அரவுண்ட் 8 to 10% சேவிங்ஸ் ஹஸ் பின் ரியலைஸ்ட். ஸோ அது வந்து ரொம்ப சிக்னிஃபிகண்ட். இது இப்போ வாங்கினாங்கன்னா, இந்த டெக்னாலஜி இருக்கிற மெஷினை வாங்கினாங்கன்னா, இந்த டிவைஸ் கோசரம், இந்த டிவைஸோட விலை மட்டும் பார்த்தீங்கன்னா இந்த சேவிங்ஸ்லேயே 6-7 மாதத்தில் பணம் திரும்பி வந்துடும். ஸோ அதுதான் இந்த மெயின் பெனிஃபிட். தேங்க்யூ.